Hello everyone, welcome back to lesson 18 for Calc AB, where we're talking about total change. In this video, we're going to really focus more on displacement versus distance and how to do it algebraically, as you guys see in example number 4, and then how do we use it on our graphing calculator. So let's go ahead and start. It says a particle moves along a line so that the velocity at time t is given by this velocity function, measured in meters per second. It says find the displacement of the particle, so displacement of the particle during the time from 1 to 4. So we want to know that from 1 to 4 of our velocity, that's going to give us s of 4 minus s of 1. So we talked about this in the first video. This right here is our displacement. Right? This is our displacement. So all you have to do in this problem is integrate this function from 1 to 4. So simple fundamental theorem of calculus. That's all you have to do. And so you would get t cubed over 3 minus t squared over 2 minus 6t evaluated from 4 to 1. And then when you do evaluate this, I don't need to show you this in the video. When you evaluate this, you're going to get negative 9 halves. Right? Negative 9 halves. So that would be your displacement over the interval from 1 to 4. All right? So we went, this would be meters, in units of meters. For part B, it says, when in the time interval does the particle change direction? So again, ladies and gentlemen, this is a blast from the past. So we're going to take our velocity function, and we're going to set it equal to 0, because we first of all got to figure out where it's at rest. Right? Remember, velocity is positive, it's moving forward or up. When velocity is negative, it's moving backwards or down. So let's figure out where our velocity is at rest first. And so we're going to do t, we're going to get, 3 and 2, looks like. And then this is going to end up being negative, this is going to be positive. So at time equals 3, and time equals negative 2. Well, we don't care about the negative, right, because we're in time. And so we're looking at the interval from 1 to 4. So we have our velocity function, and we're only carrying from 1 to 4, and we have a rest at 3. So we can plug in a number. We can plug in a number 2. 2 would be a really good example here. So we plug in 2 to our function, and we're going to get that this is going to be negative, and this is going to be positive, so we're going to be negative here, and we're going to be plus here. Now, I just want to verify that, the fact that we are changing direction here, at time equals 3. We already knew that because this is not, a double root, so we knew that. So we know that we're changing direction at time equals 3. And again, the justification for that is that our velocity changes signs. Okay, velocity changes signs. Now, for the last question, find the total distance traveled during the time period from 1 to 4. Now, what I'm going to tell you guys is you could do one of two things. So we may actually have you find the distance, total distance traveled. So what you're going to do is you would write on your paper the integral from 1 to 4, and you would write the absolute value of your velocity function, and then you'd plug it into your graphing calculator, right? You go ahead and plug it into your graphing calculator, which we're going to do here in a second. I'm going to do another example where I'm going to show you guys a quick way to find the displacement and the total distance very fast using the graphing calculator, and find that value, which ends up being 61 over 6. All right, so there's our good little answer for that. So it's in meters. However, there's going to be some times where we're going to say, okay, we want you to write out the integral that would represent the distance, but do not solve it on the interval from 1 to 4. So what do we mean by that? So this is the other way you can represent this, this total distance on integrals, just like we'd represent it here. And what the question is going to ask is without the absolute value, right? Because this is absolutely the way to do it. So how can we do it without the absolute value? We already know that our velocity is negative between 1 and 3. So we know that the integration from 1 to 3 of our velocity is going to give us a negative value. Well, our distance is going to keep this positive. We want this always positive. So if we integrate from 1 to 3 of our velocity function, again, notice now I've gotten rid of the absolute value, I'm going to put a negative in front of this, because this is going to give me a negative value. So I need to counterbalance that with this negative. And so then I'm going to go from 3 to 4 of v of t dt. So this is the way, and again, because this is going to end up being positive. So guys, when you're doing this number line, here's what happens. When you know that an integral is going to be negative, then you're going to just put a negative in front of it, because now this negative and this negative makes this value positive. This is positive, and this is already positive because it's already up here. We've already plugged in our values for this. So this is another way to get this answer without the absolute values. All right, so I hope that that makes sense to you guys. And this is another way you guys can put in your calculator, but normally if we ask you guys to use the calculator, then we just want you to go straight forward to this and use the absolute value. All right, so I hope that makes sense, and we're going to move on to question number 5, where we're going to use our calculator. All right, our calculator. So question number 5 says, a particle moves along the x-axis such that its velocity is given by the sine of square root of t on the interval from 0 to 100. The graph of v of t is shown to the right, so we have a velocity graph. The position of the particle at time equals t at x of t is at 10. It's equal to 10. Find the distance traveled from 0 to 100. Now again, this is a calculator question, so I'm going to show you guys the calculator part here now. But we want to set it up first. So the distance traveled, we do not care about our initial condition. We want the overall travel. We could be wherever. We just want to know how far we travel from 0 to 100. So we do not care about this initial condition. So we're going to go ahead from 0 to 100. We're going to go ahead and do total distance. So we want to do the absolute value of our velocity function, dt. Okay, so now let me go ahead and get my little calculator up. So you guys can see that I've went ahead and typed into y1 the sine of the square root of x. And so I'm storing my velocity as y1. And that's really a good thing for us to do because we're going to need it for our distance and our position. So we want to go ahead and store that as y1, and then we're going to get out of this. And so we're going to always do math 9, and we're going to go ahead and type in 0 and then 100 right here. Then we're going to go ahead and do the absolute value. So again, that's going to be math. Go over here to number. Hopefully your calculator is about the same thing with the absolute value. Since I've already got y1, I can go and do alpha trace, and then it's already right there. So alpha trace gives me my y1. And I'm going to go ahead and just write that my x for this. The calculator gave me 59.705. You always want to round to 3 decimal places. So 59.705. And this is going to be in, where's my units? I guess it's not giving us units, so this is our units that we have right here. I will be honest with you guys, when I did the calculator thing, it took about 20 seconds for it to actually work. So just be patient for it. It will eventually do what it's supposed to do. All right, so the next question says find the position of the particle, and we still have our calculator, right? So the position of our particle at time equals 100. So I want to know what x of 100 is. Again, ladies and gentlemen, this is an FRQ, so you want to write the notation out. You want to tell me what you're putting in your calculator. So this one, we do care about the initial. So this is our total change. So this is what we want right here. So to find the actual position, where are we at time equals 100? We have to incorporate our initial plus this. And so what we're going to do now is go back to our graphing calculator. And remember, we've already stored our function as y1, so this is why we don't have to keep typing it so many times. And for all FRQs, I strongly suggest that you guys type your functions in here, because all we have to do now is go math 9, and then 0, and sometimes you could just go ahead and then again we're going to go alpha calc 1. We do not need the absolute value for this question, so dx. And let's see if this one solves it faster. Like I said, I paused it because it took about 20 seconds for it to go the first time, so just be patient. There we go. Be patient with that. So it's going to be 15.693. 15.693, and that's going to give us 25.693. So this is the location of where we are. All right. So that's our little video on how to use the calculator to find distance. And again, guys, remember distance, you do not care about the initial value, but position you do. And we are looking for this notation. We need to see these equations written out the way that you see them here. So the last part of this video is problem number 7, where it says the particle moves along the x-axis so that its velocity is given by this crazy function. At time equals 0, the particle is at position 0.5. What's the total distance of the particle traveling from 0 to 3? This is not needed. Okay, so this is why I'm showing you guys this question. We don't care because it's asking us for total distance. This is a calculator question, ladies and gentlemen, so all you have to do is take your graphing calculator, 0 to 3. You're going to do the absolute value, and that's one of the answer choices that you're going to see on your multiple choice will be if you forget the absolute value. So you want to be very careful about that. Another answer choice would be if you added the 0.5. So this is the total distance that we want right here. This is the integration from 0 to 3 of the absolute value of our function dt. And then once you do that on your graphing calculator, you're going to get 4.181, and so your answer is going to end up being D. All right, so I think that's a good place to stop for this video. This one was really focused on the distance versus displacement. There is another question that I'm going to talk about a little bit later on visually about distance and displacement, but you guys have a good idea of that. So I will see you guys in the next video.